Okay, we're going to start chapter 6. This is a much shorter unit. We only have 4 sections to cover. We cover 6.1, 6.2, I believe 6.3, and 6.5. We'll do 6.1 and 6.2 tonight. We'll do 6.3 and 6.5 the next time. The next week you guys will test, but we will not miss a class. We will start right into that next section. I will be emailing the schedule out. It's on Canvas, so you guys have it. But we won't be missing any more classes for tests. So the tests are still going to happen just like they've been. You'll do it off-site, but we can't afford to miss any more classes. Anyway, the next few chapters are all much shorter and they move way quicker. So anyway, we'll just jump right into it. Chapter 6 is all about rational expressions and equations. Rational is a mathematic way basically to say fractions. So this entire chapter is going to be all about fractions. Okay, there's going to be lots and lots of fractions. Some are simple, some not so much. But so what we're going to start about with 6.1 is actually a couple diverse topics. The first one regards domain. Okay, the domain of a function, any kind of function, is the set of inputs. Okay, what can we put into a function that would give a valid output? Now, with fractions, okay, the numerator or the top part of the fraction doesn't really matter. The top part of a fraction can be any number in the world. Whole numbers, decimals, fractions, square roots, lots of different things. The denominator, the bottom, cannot equal 0. Okay, anything divided by 0 is undefined. It does not exist. You cannot divide something by 0. So the domain of a rational function is anything that does not cause division by 0. So in this particular function where 3 is never going to equal 0, okay, your domain would be all real numbers, everything from negative infinity to positive infinity. Okay, because it doesn't matter what you plug in for x, you're never going to get division by 0. So this you can literally plug in anything you would want to. Now, if I gave you a different fraction, something like this, okay, we need to see what values, if any, would cause the bottom to be 0, right? Because we can't have division by 0. Division by 0 causes this to be undefined. So we can basically ignore the top or the numerator, focus on the bottom and just think to ourselves, okay, what would make the bottom equal 0? And then technically we can just solve that like an equation, add 1 to both sides. Okay, if x equals 1, then my denominator equals 0. So essentially this is the number we have to eliminate. Okay, the domain for this function can be any number except for 1. Okay, if x is 1, then our denominator is 0, and this function does not exist, and that's not what we're looking for. Okay. So if they ask you something about the domain or what numbers would limit the domain, we have to eliminate any numbers that would cause division by 0. So your domain would be basically x is not 1. X can be anything else. Okay, so regardless of the rational expression, we're looking for anything that would cause division by 0. And again, the numerator doesn't really matter. And we're going to get some really ugly, elaborate, algebraic, rational expressions. And again, if they're just asking for the domain, or if they ask for limits on the domain, again, disregard the numerator. The numerator basically doesn't matter. We're just focusing on the bottom. What, if anything, makes that denominator equal to 0? Now, when we have a quadratic, that's something where we can't typically just get x by itself. So we would need to factor and solve. X squared minus 4 factors into x plus 2 and x minus 2. We set our factors equal to 0. And then x could equal -2 or +2. Either of those two numbers would cause this or our denominator to equal 0. If we plug in 2, 4 minus 4 is 0. So that would be bad. X cannot equal 2. Same thing if we plug in -2. -2 squared is 4. 4 minus 4 is also 0. So x can also not equal -2. So the very first part of chapter 6 is going to ask you, okay, what numbers would limit the domain, or what is the domain? So in this particular function, the domain is everything except for 1. Okay, we can't have 1 because that causes division by 0. In this particular function, x cannot be 2 or -2. In this particular function, x can be everything. Okay, so the domain is anything that does not cause division by 0. That's the first part. All right, the next thing, and really the bulk of 6.1, is all some type of simplifying rational expressions. Okay, now the basic idea you are familiar with. Okay, you were first introduced fractions in whatever grade, 4th, 5th, 6th. I don't remember where they introduced fractions in middle school, elementary school, whatever. But as soon as you were introduced fractions, you were also introduced to the idea of simplifying fractions. So we'll start super easy, something you're familiar with, and some people are just really good at this. But if I had 24 over 30 and told you to reduce it, okay, I'll walk through kind of the mechanics of how this works. So essentially, in order to simplify, we need a common factor. So we need to break this up. Okay, so another way to write 24 is 6 times 4. Okay, similarly, another way to write 30 is 6 times 5. Now, there's obviously lots of different ways to write this up, but I was looking for the greatest common factor here. Okay. And then once we've broken this up into a multiplication problem, okay, we have a common factor. Those common factors basically equal 1. 6 divided by 6 is 1. 1 times anything is itself. So that would leave us with 4/5. So 24/30 would reduce to 4/5. Okay, the important thing to understand is the mechanics behind this. If you take something and break it into a multiplication problem, and you've got those common factors, we can cancel them out. So that same idea, we're going to apply to some algebraic expression. For example, if they gave us something like this, okay, x squared minus 16 over 8x plus 32. And if we were told to simplify or to reduce, same thing. Okay, we have to turn this into a multiplication problem. Okay, some people get ahead of themselves and they start trying to cancel x's or this 16 and 32. Okay, when you have addition or subtraction, right, we can't just start simplifying. The only way we simplify is when we have common factors or multiplication. So all of that stuff we did last chapter where we were factoring, okay, all of that stuff is going to come into play in this chapter. Okay, so I'm going to rip through the factoring part kind of quick because we spent a whole chapter, the last, few weeks covering that same kind of thing. So this x squared minus 16 factors into x plus 4 and x minus 4. That 8x plus 32, we can factor out in 8. Which leaves me with x plus 4. And at this point now we are multiplying, so we can look for a common factor. And that x plus 4 and that x plus 4 are essentially common factors. They divide themselves out to equal 1. And then we're left with x minus 4 over 8. So that is the reduced form or the simplified form of the initial problem, x squared minus 16 over 8x plus 32. Okay, and that's basically what the rest of this chapter is. Now, they give you a bunch of homework problems. This first assignment is like 16 problems long because there's a lot of nuances to this. But basically, this is the premise behind the whole section. I'm going to show you, they give you some much more complicated examples and they add some more difficulty to this, but this is the basic premise. Okay, we're going to turn things into multiplication problems and we're going to look for common factors that we can cancel out. That's how we reduce or simplify. Okay. Now, another thing that they're going to run you into with these polynomials is there's a couple of kind of tricky things. Okay, I want to remind you that addition is commutative. Okay, we can change the order around. Now, while we can change the order, the signs still matter. So for example, 3 plus x is technically the same thing as x plus 3. Okay, with just the order is changed, right? The signs still say the same. So 3 plus x and x plus 3 are basically the same thing. So those essentially would cancel each other out and would equal 1. However, if it is subtraction and it's inverted, okay, that's not exactly the same thing, because in this case, we've got a positive 3 and a negative x. Here we have a positive x and a negative 3. So if we change the order, they're not exactly the same thing. But if you remember, okay, we can fix that by, we factored out a -1, or if we divide both of those by -1, then negative divided by negative is a positive, positive divided by negative is a negative. Okay, so that 3 minus x over x minus 3 does cancel out, but then we're left with a -1. -1 over 1 is just -1. So if basically if it's a plus and the order is flip-flopped, that doesn't matter. Those still cancel each other out. If it's a minus and those are flip-flopped, they're going to reduce to a -1. So like I said, they're going to try and trick you with this. So if they did something like x squared minus 49 over 21 minus 3x. Okay, again, this factors into x plus 7 and x minus 7. Here we can factor out a 3, and that leaves us with 7 minus x. And again, once you've got this into a multiplication problem, you're looking for common factors. We've got x minus 7 and 7 minus x. Those are similar, but not exactly the same. They do cancel, but not to be a positive 1. Remember, if you've got inverted and they're minus, that cancels to be a -1. So then you're left with -1 times x plus 7 over 3. Okay, anyway, like I said, that's the premise. So they're going to give you some big algebraic fraction. You have to factor it, but then cancel your common factors. That's how you reduce or simplify. Now, they're also going to apply that same concept to multiplying fractions. Now, multiplying fractions, okay, again, I'm going to go back to elementary / middle school. Okay, the premise behind multiplying fractions together is that you just multiply straight across. If you have a fraction times another fraction, you multiply the numerators. 2 times 3 is 6. You multiply the denominators. 5 times 7 is 35. So that would give us 6/35. Okay, within that same thing, within multiplying, we can do this thing called cross simplification. Okay, so if they gave us a problem like 10/35 times 21/15, okay, one option is to do that the same way, just multiply straight across, and then we would get 210 over 525, which we would then need to reduce. You got to try and find greatest common factors out of these, but these numbers are gigantic. Okay, they're huge. There's an easier way, more straightforward, in my mind, a better way to go about doing this exact same problem. So if we apply that concept of factoring, so another way to write 10 is 2 times 5. Okay, another way to write 35 is 7 times 5. Another way to write 21 is 3 times 7. Another way to write 15 is 3 times 5. Now, in multiplication, okay, again, we multiply straight across. So this is ultimately 2 times 5 times 3 times 7. Same thing, this is 7 times 5 times 3 times 5. So within all of this, as long as you have common factors on the top and on the bottom, they would cancel each other out. So for example, this 7 and this 7, because we're all multiplying here, okay, are common factors. This 5 and this 5, likewise this 3 and this 3. So then all we have to pay attention to is what wasn't able to be canceled. And in this case, we would reduce all the way down to 2/5, which in my mind is much easier than trying to reduce that 210 over 525. So anyway, if you can take multiplication and break it into its factors, it's basically just a bigger problem of the same kind of thing we were just doing with simplifying. So if we apply that same concept to some algebraic expression, like okay, we can rewrite these by factoring. And again, turn this into one big multiplication problem. So this 32x minus 12, we can factor 32 and 12. We can factor out a 4. (32) is divisible by 4. 12 is divisible by 4. We divide 4 out. That means with 8x, 12 divided by 4 is 3. And same thing, multiplying. 14 is 7 times 2. 49 is 7 times 7. And while we can't factor anything out of 3 minus 8x, we don't necessarily need to. And now we're all multiplying. Everything here is a multiplication problem. You got 4 times 8x minus 3 times 7 times 2, 7 times 7 times 3 minus 8x. So again, once we're strictly multiplying, we can cancel any common factors. Those 7s cancel. Now here, 8x minus 3 and 3 minus 8x. Those are almost the same, but that's that flip-flopped thing. So 8x, negative 8x, negative 3, positive 3. Those cancel into a negative 1. So then what we're left with is 4 times 2 times negative 1 all over 7. Then I would go ahead and reduce that. 4 times 2 is 8 times negative 1. So we would get a negative 7. So you can go from having some really ugly algebraic fraction with x's and numbers all over the place, but you can actually reduce that down to a pretty little numbers only fraction. So that's what we're doing with this. You're taking some big, huge, ugly algebraic expression, breaking it into factors, and looking to cancel any and all common factors. So again, common factors mean top and bottom. Okay, we can't cancel factors that are on the same. So like we didn't cancel those two fives because they're both on the bottom, but one of those bottom fives can cancel with that top one. Okay, like I said, some of these examples get really hairy. This is one of the ugliest ones in my estimation that you'll see. All right. Gross. All right. So when looking at a problem like this, okay, ultimately the big step, the only way we can do this is to factor. Okay, so go back, look at the zooms from last chapter if you don't remember, but we need to be able to factor all of these things. Okay, whether it's got 2 terms or 3 terms, or there's a leading coefficient or not, you need to be able to factor. So I'm going to rewrite this. So this 9x minus 18x to the second, we can factor out a 9 and we can factor out an x. Those are both divisible by 9. They both have x's. So if I factor out that 9x, I'm left with 1 minus 2x. This 2x squared plus 3x plus 1 factors into 2x plus 1 and x plus 1. Okay, 4x squared plus 4x plus 1 factors into 2x plus 1 and 2x plus 1. And 4x squared minus 1 factors into 2x plus 1 and 2x minus 1. Okay, this one was difference of perfect squares. This is a trinomial with a leading coefficient. Same trinomial with leading coefficient. This one we just factored out a greatest common factor. Okay, all stuff we did last unit. But once we get this down to where, again, it is all multiplication, we can look for any and all common factors. For example, 2x plus 1 and 2x plus 1. Another 2x plus 1 and 2x plus 1. Now again, 1 minus 2x and 2x minus 1. They like to do this where you'll have the same numbers, again with a subtraction where they're just inverted. So again, that's a one where they reduce to a -1 instead of just a positive. So when you look at what we're left with, we have a -9x and an x plus 1. So this big, hairy, ugly problem reduces all the way down to this nifty, neat little -9x over x plus 1. All right, the last thing they're going to do in 6.1 is more of the same with one little wrinkle, division of fractions. Okay, 2/5 divided by 1/3. Okay, with division, we don't actually do division. To divide fractions, we change division to multiplication, and we multiply by the reciprocal. The reciprocal is a fancy way of saying we flip that second fraction over. My wife used to teach junior high math, and she would call this flip flop wop. Okay, I don't care what you call it necessarily, but when you divide fractions, the mechanics are ultimately to multiply by the reciprocal. So notice this first fraction, okay, the dividend, whatever we're dividing by, okay, or whatever is being divided, doesn't change. So 2/5 stayed. Now the divisor, okay, is the one that we take and reciprocal, right? So again, 2/5 divided by 1/3 becomes 2/5 times 3/1. Then it's more of the same. Multiply straight across, that would be 6/5. So division is really just multiplication again. You just multiply by the reciprocal. So when they give you a division problem, 2x over 9 divided by 8x plus 16 over 9x plus 18. Okay, we're just going to take that. We're going to change the division to multiplication, and then we reciprocal our divisor. So that 8x plus 16 on the top becomes 8x plus 16 on the bottom, or in the denominator. 9x plus 18 on the bottom becomes 9x plus 18 in the numerator. Then it's basically multiplication, which goes back to all of the same stuff we were just doing. So we still need to factor. Okay, here we can factor out a greatest common factor of 9. Here we can factor out a greatest common factor of 8. And again, we're looking for common factors like your x plus 2s and your 9s. Okay, 8 can technically be written as 2 times 4. In this case, my 2s cancel. So that leaves me with x over 4. Or 1/4 x, same thing. So that's basically 6.1. So the first part talks about that domain and what would be the limiters. Okay, from there, it's a bunch of types of simplification. They start with just one fraction where you're still going to factor and simplify. Multiplication is more of the same. You've just got more pieces to factor. And then division is more of the same. We just change it to dividing, or change division to multiplying by the reciprocal. I do, again, want to remind you, make sure you are staying on top of your homework. Okay, like I said, this particular assignment, I think, is 16 problems, and it's a bunch of problems that are all really doing the same kind of thing over and over and over again. So make sure you're staying on top of your homework and getting it done. Some of you are doing really good with that, and it shows on your test scores. Those of you that are doing really well on your homework, guess what? You're doing really well on your test. Good job. Okay, those of you that are not, aren't. So here's a piece of advice. Do your homework, okay? Make sure you're staying on top of that. All right. Transitioning from 6.1 to 6.2. 6.2 is all about adding and subtracting fractions or rational expressions. Okay, much like simplifying, we're going to go back to what I would call, say, elementary-ish. Okay, when you first were introduced to fractions, show you the concept, and then we'll apply it to the algebraic expressions. So, for example, okay, the mechanics for adding and subtracting fractions is you need to have a common denominator. Okay, in math, you can only combine like terms. Okay, you can only combine things that are alike. With fractions, that means the bottom pieces. Okay, you remember adding like pieces of the pie. This is 1/5, this is 3/5. Okay, if you have 1/5 and you have 3/5, if you add those together, you would have 4 of the 5 pieces, or 4/5. So in order to add, you must have common denominators. And when you do, that denominator stays the same. It doesn't change. So again, that's kind of like the descriptor. Okay, we're breaking this thing into fifths. So my answer is going to be in terms of fifths. And then you would just simply add or subtract the numerators. Okay. If they change this to an algebraic expression, it's still more of the same. Okay. In order to add your fractions, you have to have a common denominator. If you do, you keep it. So this is in terms of x plus 1. This is in terms of x plus 1. My answer is going to be in terms of x plus 1. So you have to have that common denominator in order to add. And if you have it, it stays. Then similar, just add the numerators. If we're adding expressions, remember you can again only combine like terms. So 4 plus x plus 3 plus 2x. We can combine the 4 and the 3 into a 7. Combine the 1x and the 2x into 3x. This doesn't factor, this doesn't factor, no common factors. This is simplified. Now, subtraction plays the same. The one thing I want to caution you on is if you're subtracting a quantity, you do need to distribute that negative. So if we did more or less this same problem, but if it would have been subtraction, okay, subtraction is simply adding the opposite. So when you subtract a quantity, you need to distribute that negative, and we add the opposite. Still keep our denominator. Combine our like terms. So 4 plus negative 3 is 1. X plus negative 2x is negative x. Now it does look like we should be able to simplify this. However, one's a plus, one's a minus. We're not multiplying. We can't cancel those x's out. This is addition. Okay, remember, in order to simplify, you have to be multiplying. This actually is considered to be reduced or simplified. So in order to add or subtract, you have to have a common denominator. When you do, you keep it. If you're subtracting a quantity, make sure you distribute that negative. Now, unfortunately, they take things and make them considerably more difficult, okay? Because what if we don't have a common denominator? All right, what if we needed to add 1/5 plus 2/3? Okay, we don't have a denominator to keep, but it's easy to get a denominator. What we do is we essentially can multiply. If you multiply your denominators together, okay, that ultimately gives you a common denominator. Now, we can only do that because equivalent fractions, whatever I multiply to one side, as long as I multiply it to both the numerator and the denominator, we're just creating, okay, a common or equivalent fraction. So 1/5 times 3 is essentially 3/15. We multiply that 5, okay, 2/3 times 5/5 is 10/15. So that gives us equivalent fractions. So 1/5 is the same as 3/15. It's basically just unreduced. 2/3 is the same as 10/15. Same, it's basically just unreduced, but now we have a common denominator. So we can add and get 13/15. Okay, I was going to do the same thing, basically do it up here, just show it in multiplications. We've got 3 times 1 plus 2 times 5 all over that 15, which again, 3 plus 10 is 13/15. But this concept of multiplying your denominators together to guarantee a common denominator is again the mechanics for when you have an algebraic expression and you do not have a common denominator. Okay, so if they gave us something like this, 2 over x plus 1 plus 3 over x plus 2, we can't add these together because we don't have a common denominator, at least not yet. So what we need to do is we need to multiply this over here. And we need to multiply this one over here. So again, that's going to give us our common denominator of the quantity x plus 2 times x plus 1, because as long as we multiply those two things, now we have an x plus 1 over here and over here. We have an x plus 2 over here and over here. Those are now the same. But again, we can only multiply this over here if we multiply it to the top as well. Same, this x plus 1, we can only multiply if we multiply it by the top as well. So whatever you're multiplying to the bottom, you also have to multiply to the top. So if we distribute, we get 2x plus 4 plus, we distribute, we get 3x plus 3. Now, technically we could distribute this, but you don't have to. So I would just leave it factored. That also might help us if we end up needing to simplify something. So we can leave our denominator in its factored form. You don't need to FOIL those two things together. So I'm going to leave this as x plus 2 and x plus 1. But we do have like terms that we can combine from our numerator. For example, 2x plus 3x is 5x. You can also combine positive 4 and positive 3, which is positive 7. And then this is my finished answer. So 2 over x plus 1 plus 3 over x plus 2, our original problem, equals 5x plus 7 over the quantity x plus 2 times x plus 1. So when you don't have a common denominator, that makes these problems considerably more complicated. You have to multiply to get it. Whatever you multiply to the bottom, you got to multiply to the top. Distribute. Same. Whatever you multiply to the bottom, you got to multiply to the top. Distribute. That's where these came from. Combine your like terms. Keep your common denominator. And that's that. Now, unfortunately, again, these get even more ugly and complicated. Ugh. All right, one thing that will help, especially with the denominators, if you can factor, I would do so, because again, we're looking for a common factor. And while I can multiply this x squared minus 1 over here and this x plus 1 over here, we don't necessarily have to do that. Okay. If you can find common factors that already exist, there's no need to multiply them over. So what I mean by that is, okay, this 3x over x plus 1 is fine. Okay. But this x squared minus 1 actually factors. X squared minus 1 is x plus 1 times x minus 1. This and this are the same thing. This is just the factored form of this one. Okay, so if we look, again, in order to add or subtract, you have to have a common denominator. And technically, we have an x plus 1 here. We already have that here. So technically, to get our common denominators, the only thing I need to multiply is I need an x minus 1 on the left here. Then we have x minus 1 and x plus 1, just like over here. I already have x minus 1 and x plus 1. So again, if I multiply that, I got to multiply that to the top. Distribute. So we get 3x squared minus 3x over x minus 1, x plus 1. Remember, this one, we didn't have to multiply anything. We already had both of those from our original problem. So we just keep that. So now we have our common denominator, x minus 1, x plus 1, x minus 1, x plus 1. So we keep it. Again, subtraction is adding the opposite. 3x squared, no like terms, it stays. Negative 3x plus negative 3x is a negative 4x. That is your completed simplified sum or difference. So if possible, go ahead and factor. All right, that might make it easier to find any and all common denominators without having to reduce anything. Okay, one more, actually two more examples. All right, so this is one of those problems where you are going to want to factor those denominators, okay? This is really ugly. So is this. If we tried multiplying this denominator over here and this denominator over here, there's a ton of distribution that would have to happen, okay? And ultimately, there's a lot of common factors. We would end up having to factor some stuff, and that would get ridiculously ugly. So again, go back, revisit previous Zoom lessons. Remember factoring when you have a number in front of the x squared. But if I factor that denominator, that 4x squared minus 7x minus 15 factors into 4x plus 5 and x minus 3. Okay. Similarly, that 2x squared minus 5x minus 3 factors into x minus 3 and 2x plus 1. So when it comes to getting a common denominator, we've got an x minus 3. We've got an x minus 3. I don't need to add anything to those. That's already here on the same side. Okay, but this 4x plus 5, I don't have one of those here. So I got to multiply it. Okay, whatever you multiply to the bottom, you got to multiply to the top. Okay, this 2x plus 1, I've got one of those here. I need one of those over here. Multiply that. Again, whatever you multiply to the bottom, you got to multiply to the top. But now we've got that common denominator. So this is the only thing that we needed to multiply in order to get that 2x plus 1, 4x plus 5, and x minus 3. So that's my common denominator. Now, multiplying these numerators, we do have to do that distribution. So I got to multiply these two things together. So 2x times x is 2x squared. 2x times 9 is 18x. 1 times x is 1x. 1 times 9 is 9. Okay, again, plus x times 4x is 4x squared. X times 5 is 5x. Now we do have some like terms that we can combine, so we need to do that. 2x squared plus 4x is 6x squared. 18x plus 1x plus 5x is 24x. 9. There we go. Now, technically, we can factor these by 3. We could factor out a 3, but it's not necessary. It doesn't cause anything to simplify again. So I would call this simplified enough. The only reason to factor something out would be to then if we end up with some sort of common factor, but nothing else simplifies. This is about as ugly as it gets. Okay. We don't have anything worse, in my opinion, than what we're looking at right here. But they will throw problems like this at you in your homework and on the test. So be ready for that. One more example. Okay. If they give you multiple addition and or subtraction problems, okay, they all have to have common denominators. In order to add or subtract, again, you must have common denominators. If they give you multiple problems, they all need to have the same denominator. So we're going to do all of this kind of all at once. Again, I would factor, because you only want to multiply by the stuff you have to. X plus 3 doesn't really factor, so we'll leave it. However, 3x plus 9 does. I can factor out a 3. Similarly, 2x plus 6, I can factor out a 2. So if we're looking at our denominators, this one's got an x plus 3, this one's got an x plus 3, this one's got an x plus 3. We don't need to do that. Okay, that's good. It's common to all 3. There's just the 1. Now, this one's got a 2, where this one doesn't. So here we need to multiply a 2. This one's got a 2, this one's got a 2, but this one doesn't. So we need to multiply a 2 here. Now this one's got a 3 and these don't. So again, we need a 3. So now we've got that common denominator of 3 times 2 times x plus 3. So again, it's about getting that common denominator. Okay, 3 times 2 is 6 times 4, so that's 24. 2 times 12x is 24x, and that's minus. 3 times 1 is 3. Combine any like terms. We can combine this positive 24 and this positive 3, so that's 27 minus 24x. Now, this is an example where we can factor the numerator and something will cancel out. So again, if we look at 27 and 24, those are both divisible by 3. If we look, now we've got that common factor. So again, it has to be multiplying, but that common factor of 3 cancels. So we're left with 9 minus 8x over 2 times x plus 3. All right, I realize I went through a lot of stuff. I went pretty quick. I will have this recorded. I will put it in the Canvas as well as the lesson from last year. So good stuff to go over. You can slow it down. You can kind of replay parts. If you have questions, email me. This is a fairly difficult chapter. There's only 4 sections, but just because it's fractions, I kind of joke around that that's one of those math cuss words. Okay, the math F word is fractions. People don't like them. They're scared of them or whatever, but there's going to be a bunch in this chapter. So you're going to get to play with them quite a bit. So do your homework. If you have questions, you can email them to me. You know, if you have something, take a screenshot and be like, I don't know exactly what I need here. You can send that to me and I'll do my best to kind of walk you through it. But this is one of those things you got to do problem after problem after problem. And about the time you think you understand it, they're going to throw you some crazy curveball that doesn't make sense. So anyway, let me know if you have any troubles. But that's all I've got for tonight. If you've got some questions, obviously I'm here for another little bit, but I'm going to go ahead and stop the recording. And then if you're done, you think you got it, you are free to go and you can spend some of this extra time working on your homework. Okay. So I'm going to stop recording, but if you have questions, ask them.